Hello everyone, I'm Jack. Today let's take a look at this new problem, 1041, robot bounded in a circle. Well, it is actually marked as easy, but I took some time to figure it by myself without looking at the materials, so it should be easy. On infinite plane, a robot initially stands at 0, the original point, and faces north, and the robot can receive one of the three instructions. Go straight 1 unit. L, turn left with 90 degrees, right, turn 90 degrees. The robot performs the instructions given in order and repeats them forever. Okay, so return true if and only if there exists a circle in plane, such as the robot never leaves the circle. To think about this, that first, the instructions could be coming in some random input. It's like they will just go left and right, right and left. So just repeatedly, maybe the instruction may be long as 100. So they just go randomly. So actually, the most important thing is about the last point. So I finally figured out that we only need to take care about the last in one iteration. The last point, the last coordinate is the most important one. Say that I'll draw this later. Okay. At first, since I already draw this map, this graph, I first handle the rotation, because we have two commands, which is L and R, which commands the robot to turn left or turn right. So let's take a look. Let's create a function called rotate. It's receive direction, and the order is, oh man, I want to rewrite TypeScript. Is there TypeScript? No shit. Okay, I want to write TypeScript anyway. So direction is an array consisting the horizontal axis and the vertical axis. So when we rotate it with L or R, how can we rotate them? So this leads me to remembering the matrix thing, rotating the matrix, but I forgot. Man, I really forgot. So I haven't touched the matrix for 10 years. So I will draw this map. So to recall the calculation, so this is the dot xy with the product of 1. This is product or length, I don't know. So anyway, so this line is a length of 1. Suppose it's 1 unit. So this x here, x, y, and so we rotate it. With theta. Okay, it's weird. Sorry, I'm using my touchpad, and so this is a new coordinate x. What is this? New x, new y. Anyway, x5. Anyway, x1 and y1. Let's say x1 and y1. We're going to get the x1 and y1. How can we get it? So we draw this new dash line to help us understand what is going on. We draw it with red. Okay. So actually, okay, it is outlines also need to be red. oh shit, we need to draw it with a line. It's weird. I'm drawing a line, not something. There's no fill, sorry. Wait. There should be no fill. No fill. What pattern? Man, this is really. I don't know what it is. I don't know what this is. Shit. Anyway, I'll draw a line here. Oh, okay, it's working. Okay, and we draw a line here. So this is also a line we draw. So this is the 90 degrees, and we can see that. Oh, sorry. This is a disaster. Pencil. Here it's also theta, and this is theta. So this is theta. Oh, this is not theta. It's something not theta. Let's say it's it's what is it? It's, let's say it's alpha. Okay, this is alpha, then this is alpha, and this is alpha, right? So now we calculate this x1. So x1 is actually this is x1. This is x1. So actually this is this part minus this part. So it's actually, we can see that x1 equals this part. We first calculate this part. So this part means this part. This part means this one. And sine alpha. Sine alpha, actually, because we're at the unit of 1, it's y. So we know that this one, this length is cosine theta. So it's cosine, forgive my bad handwriting, and multiple by y. So this is this part, okay, minus this one. This one is this one, actually. So it's sine theta. Wow. Oh, sorry. And sine theta is this one. So this one, and sine alpha, so it's also y. Wait a minute, something is wrong. It's actually oh, sorry, I made a mistake. This is cosine theta is this one, but it has to so this area is not times y, but to the proportion of cosine theta. So actually it should be times x. My bad. Okay, this times x. We do the same. Y1 equals this part plus this part, right? So this part means we can do the same. So the proportion is cosine theta, actually divided by 1. So but it's the same, and we multiply it by y, so this is this part, okay, plus cosine. Cosine alpha means x, so we actually x cosine alpha means x. Yeah, and this one is sine theta, so sine theta. Oh shit. Ooh. Times x. So we got this formula of calculating the rotation. It's cosine theta for 90 degrees with 0. Sine theta is 1. And the cosine theta is 0. Sine theta is 1. So actually we got this formula. Return. So new direction is minus y. So actually for this one is 90 degree is for L, turning left, because it's counterclockwise, and so it should be direction 1, and y should be sine theta, so x direction 0. But this is the case of order equals L. Okay. If not, if it's to the right, we say the same. Only say this one is same, but this one is minus 1. So okay, minus 1. So it should be direction 1, but minus direction 0. Okay, we got this rotate thing, and now we need to calculate. We need to find out the pattern of the problem. So oh wait a minute, shit. This is the coordinates. Let's say it start here. So no matter how we move, we can forget about everything. No matter how we move, if we take the last point into consideration, we say last point yeah, and so the original direction is like this, right? Okay, change the pen. Oh, change it to pencil. This is the original direction. If the end point is here, and the last direction is like this. If something is like this, let's say, and this is last point, it means that we first move from the origin directly to this point and rotate it by this angle. Now, if we want to circle it with like this kind of a circle, if we draw a line out of this circle, you can see that if we want to surround them, to make it within this circle forever, we need to at least, right, move our angle like for 90 degrees. Say if this angle is like this, it cannot be kept within a circle. Why? Let's take a look again. Because you only move it like this angle, like this, let's say 17 degrees, and for these cases we will still move 90, not 90 but 60 degrees, okay, like this, and you will just get further and further and further. You will not bound it within a circle. I'm not sure I'm explaining it right, but it's to my instinct that it should be the same. It should be something like this. If you want to draw a circle, we make it we move it like the half radius. First move half radius, and then we just take the 90 degrees as the angle and draw a line. And if we follow this rule and like repeat it for forever, it will finally leads us to a circle, full circle, right? If you want to keep it, we need to a smaller angle. If not, we will make if not like we are like a larger angle, we will not draw a line. We'll just draw a line like I don't know what the name, but it's something like the snail, the shell of snail, right? Yeah, you will not. Yeah, it's free. Yeah. Oh yeah. If it's 90 degrees, we say it's a circle. If it's not, it's more than 90 degrees. It actually will be a reversed snail shell, and finally merge to one point. So actually, we were calculating the final angle versus the start angle, the end angle and the first start angle, to see whether the new angle, the degrees that we need to rotate, is smaller than 90 degrees or bigger than 90 degrees. One thing is that, one exception is that if this only works when we have moved to a little bit. If we always stays at the origin, no matter what the angle is, we can keep it in a circle because it's always in the origin. We don't need to care about anything else. So we need to take the origin as a special case. So okay, so for the instructions we get, we need to get the final final coordinates and the final direction. Let direction, as we are told that the initial direction is north, so it should be 0, 1. Let core power position equals 0, 0, and for let's I equals 0, total equals instructions dot length I smaller than total I plus plus. If instruction equals instructions I, if instruction equals G, then we just say remove it. We move it by plus 0 plus 1. Oh shit, I cannot do object assign post 0 plus equals direction 0 plus 1 plus direction 1. If it's not go, we need to rotate the direction. So direction equals rotate direction rotate instruction. Actually, I found a problem that we are returning new array, which is not performant. We actually don't need to keep the history, the direction histories when you kept the current. So I'll just say direction const temp. Wait a minute. I'll say direction one direction equals. I'm not sure where this is working. Let me try in the console. Const a equals 1 2 a0 a1 equals a1 a0. Now okay, we can reverse it. So equals this. We're not creating a new. By this, we're not creating a new array. I'm not sure this is right, but maybe not. Okay, we just forget about it. Okay, and then we finally check if we are still at the origin. If pos 0 equals 0 and pos 1 equals 0, return true. Else, check if direction changes bigger than 90 degrees. So how can we check it's bigger than 90 degrees? Well, this is another formula. It's cosine theta, cosine alpha, okay? Alpha cosine theta. I like theta. Equals for two vectors, we need to calculate the theta. Let's get the we remove the graph. Actually, I'll just memorize it. So it should be a vector A, B divided by A, the value of A, the value of B. This is at least what I remember. Maybe it's wrong. Maybe it's right. It should be right. Okay, we calculated the cosine and check if it's bigger than 90 degrees. If it's not bigger than 90 degrees, it should be a minus. So return cosine is smaller or equal. It's not if it is not a positive number. So A times B means direction. So here we are calculating A direction, B 0 1 because this is the initial direction. So A times B equals, the first one is gone, and 1 times direction 1. So direction 1. Actually, the direction is 1, so... Wait a minute. Am I getting this right? Because... yeah. Because this one is absolutely bigger than 0. So this should be 0. We're done. We run the code. There's a typo here. True. Yeah, let's submit it. Ooh, wrong answer. We got GL. It means... Why? Let's check if... Direction. The input is GL. Yeah. My bad. It should be or equals that, equal to 0. Wrong answer. I like debugging. Need to console log direction. Okay, final direction. So LL. Okay, it's down, and then move 1, right, and L. So actually, the final direction is not. Oh, there's a problem. We have a problem. We log the rotation. Okay. The first, we write left, so it's right. And then down, right. And then we are moving right, so it should be, oh, we made a mistake here, so actually, ha 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 ha. My bad. Oh, my bad. Submit again. Accepted, yay! We got faster than 85% of the submission. Not bad. Let's take a look at the other solutions. Wow, they are really fast. Rotation 0, blah blah, instructions, West G, case swap, break, blah 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 blah. Rotation, blah blah blah. Return 0 or so they're actually we're doing the same, but it seems that we are losing some time by calling a function. If we inline this function, will it help? Okay, if instruction L, we just to say equals this, else, if not, wait, modify this. We can remove this rotate. Submit. Something weird happened. Doesn't. Sorry, my network seems down. No, the server is down. Oh, okay. I don't know. Actually, this seems not helping. Anyway, we are not doing that bad. I'll stop today. Hope this video helps you a little. And see you next time. Next time we are working on this one, flowering planting with no adjacent. Okay. Have a good night. Bye bye. OBS is not working.